Let me show you how to be a good Bayesian.
Today, I am thrilled, nay, I am honored to have Chris Fonnesbeck on the show, a trailblazer in sports analytics and PyMC's BDFL. Chris's journey has spanned marine biology, sports modeling, particularly in baseball, and broader statistical consulting, making him a key figure in the intersection of sports, data science, and decision making. In this episode, Chris reflects on the evolution of sports modeling from the early days of limited data to the current era of high-frequency and hierarchical datasets. He shares how Bayesian methods have been instrumental in navigating messy data and building robust models. We dive into themes like the importance of model transparency, iterative development, and balancing simplicity with complexity. Along the way, we discuss technical approaches like Gaussian processes, structural time series, and data simulations, exploring their practical applications in sports analytics, but also beyond. Whether you're a sports enthusiast, a data scientist, or someone curious about the growth of Bayesian methods, this episode is packed with insights and lessons learned from years of experience in the field. This is Learning Bayesian Statistics, episode 125, recorded November 6, 2024.
Let me show you how to be a good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. What's a Bayesian? It's someone who cares about evidence.
Welcome to Learning Bayesian Statistics, a podcast about Bayesian inference, the methods, the projects, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. For any info about the show, learnbayesstats.com is la place to be. Show notes, becoming a corporate sponsor, unlocking Bayesian merch, supporting the show on Patreon, everything is in there. That's learnbayesstats.com. If you're interested in one-on-one mentorship, online courses, or statistical consulting, feel free to reach out and book a call at topmate.io/Alex_Andorra. See you around, folks, and best Bayesian wishes to you all. And if today's discussion sparked ideas for your business, well, our team at PyMC Labs can help bring them to life. Check us out at pymc-labs.com. Chris Fonnesbeck, welcome back to Learning Bayesian Statistics.
Thanks for having me. It's been a while.
Yeah, it's been 5 years exactly. Yeah.
So I was the second guest ever.
You were the second guest. First ever was Osvaldo Martin.
That's right.
And he was back on the show a few weeks ago, a few days ago. And now it's you. So I've done a full circle of all the Bayesian guests. So now
you got to go back to the beginning. There's no new ones.
Exactly. I had to invite you back. Like I had no choice. Yeah, it's like
through the population.
No, of course, it's a pleasure to have you back here because you've done a lot of things in 5 years. So it's awesome to have you here. We're here in New York because we're going to teach our Gaussian processes tutorial in a few hours. And that's really a fun turn of event for me because like when I started learning Bayesian statistics 5 years ago, one of the first tutorials I watched was one at Pilot New York. About
processes,
Bayesian inference, Gaussian processes.
Yeah.
And you know who was teaching it?
Me.
Yeah. so that's pretty cool.
There we go.
Now, 5 years later, we're here.
We're here together.
That's great. And an honor to teach with you this afternoon.
Yeah, it's going to be good.
Yeah, I hope so.
Yeah.
We're taping that before so that then we don't have any feedback, so that we cannot say that it was bad.
I see.
That's smart.
Yep.
That's the French way to do it.
Good idea. Editing.
Exactly. So last time you were here, I think you were still working for the Phillies, right?
If it was 5 years ago, it would have been the Yankees.
Oh, so you were still at the Yankees. Okay. So lots of things since then. But so everybody knows you. You're PyMC BDFL. You've done a lot of marine biology statistics. You've done a lot of sports modeling. What I'm curious about is how did you end up doing sports modeling? Because it's a bit like me, right? You didn't start doing
sports modeling from the get-go, and that was like your thing. So how did that happen?
Yeah. Yeah. I mean, part of it was timing related, right? Because in the sort of late 20-teens is really when these new sources of high frequency data started becoming available, or at least in baseball. So you had pitch effects, and then TrackMan, and now we have Puckeye. And, this is providing baseball with streams of extremely high resolution, comprehensive sources of data on everything that moves on a baseball field. And so at that point, that industry began looking for people that could deal with data of that scale and use them in useful machine learning and statistical models. So it was no longer the realm of, a baseball person with a spreadsheet, to have more than that. And so around that same time, I was at Vanderbilt in the biostatistics department, and, all of these jobs started appearing in various places. And I actually, before that, I started with, for a short stint with the Milwaukee Brewers, just to kind of, as a consultant, to kind of see what the industry was like. And I didn't have to give up my, tenure track academic job. But, I never envisioned myself being an academic in the first place. So it wasn't like it was a long-term goal of mine. It's just kind of where I ended up. And so I knew I wouldn't spend my whole career in academia anyway. So I think it was just kind of the next chapter, and it felt kind of like a natural transition into sports, which, I've always been interested in. I played sports when I was young, but not particularly well. So, so the analytics side kind of always appealed to me. I like data science. And it was a nice kind of intersection of my interests and skills. And so that's kind of how it went about. And, it continues, and baseball is still, there are still teams that don't have a lot of quantitative support, although it's more widespread than it once was. And then, beyond that, since I've left baseball, you've talked to people in other sports, and you see kind of how far behind some of them are relative to baseball. So there's still a lot of opportunity out there.
Yeah, for sure. And how was were you a baseball already fan or amateur before you joined the Yankees?
Yeah, I mean, I've followed baseball, my whole life, and I played when I was in high school. So, yeah, as an amateur observer, never in any professional capacity. So you definitely, you get the imposter syndrome when you get in there. You go from nothing to working for a Major League Baseball team, which doesn't seem right in some respect, but you've got the skills that they need, and so there you are. But so yeah, it was always great to be able to go to the ballpark and work there, and hopefully contribute towards the success of the team. So so it's fun. It was a fun time.
Yeah. And did you find that the Bayesian methods were really helpful there? How was your experience with all the, because working for a team, what I find also personally now that I've been there for just a few months, but it's you have all these interactions between the data engineers, you, the modeler, and then how the models are used, how they are interpreted. So what was your experience here? What was maybe the hardest, the biggest hurdle that you had in this workflow? And how did you find that Bayesian stats were helpful, if they were at all?
Yeah, so two parts there. First, the Bayesian stuff. I think the enlightened teams know the value of Bayesian methods, right? Because while you have large quantities of data that, you would think, machine learning would be kind of the first stop. And certainly a lot of machine learning methods are used. Those data are still messy. They are naturally hierarchical, clustered with covariates and sources of noise. So just throwing them into, an XGBoost model or something like that, kind of naively, isn't always the optimal way to move forward and get the most out of that data. So Bayesian methods, are really kind of as it often is kind of a natural choice, with the usual trade-off that, the computational side can be very challenging, right? When you've got, if you're using every pitch thrown, over a 10-year period, that's a lot of rows. And so, PyMC and Stan will start to struggle. So one of the challenges was, getting everything to work with, I wouldn't call it big data, but, uncomfortably large data is always a challenge. And then, coming from academia / software, open source software development, just, the whole productionization of the model is a challenge, right? So getting it up and running quickly so that it can be used to make decisions is, that's always a big challenge. You're never quite finished with it. It's kind of, knowing when to stop and put something into production, in a way that's helpful, again, to the decision makers. And that's always challenging. And then you got to work within the framework of, of the company, which is, how do they store their data? How do they store their models? How do they interface the outputs from those models to players, coaches, and the front office? And that's different from
one
team to team.
Yeah. And so precisely, how did you, were you the one, communicating these models? How did you, or were you just like, making the models and then other people were communicating them? But if you were communicating them, what was your way of doing it so that the decision makers really could use the model to its full potential?
At least in the case of the Phillies, it was a very transparent research and development team where you had access to the decision makers. They were always close by, and it was a large group of analysts there that worked closely together. And so kind of everybody knew what everyone else was doing. So, the usual way, you'd write reports, you'd productionize a model, and it would appear, the results of that would appear on, kind of a dashboard for people to access. So, my experience was a fair level of transparency. But I've heard stories and I know that in some instances that's not always the case, that your work can be a little bit siloed and isolated, and decision makers aren't always using that information optimally or at all in some cases. And so that I was fortunate to avoid those sorts of challenges, which I would imagine can be a little disheartening, doing lots of analytic work with interesting data and then not have anybody put it to use. So we were very fortunate, and we're seeing the teams that do those sorts of things are successful, and those that don't, I think, tend to have a harder time. They have to get lucky a little bit more.
Yeah, and like in your experience communicating the distributions, was that something useful, or were you more into point estimates, showing the tails of the distribution? How did that work?
Yeah, I mean, at the end of the day, I think, point estimates are still important, but it's good to know, how much uncertainty is associated with them. And that's still a challenge, I think. At the end of the day, people want lists to make decisions with, and it's hard, you're always taught in, doing Bayesian inference that, you carry that whole distribution with you and it's got all the information, but we're often still using, point estimates. And, but it does, you can, using communication tools, you can convey some of that uncertainty in ways that are interpretable and useful to people. You can say that, two players are, while their mean is slightly different, there's huge overlap in the uncertainty and they're essentially the same player. And so you shouldn't sweat over choosing between one or the other and that sort of thing. So, so it's still important to, have those avenues for communication and making sure that they're aware of the limitations of the data. These are outputs of models, and models are wrong. Some people either overly trust or under trust a model, and over trusting it can be just as bad as under trusting it in certain situations. It's just the output of a model, and so everything is, I think, good decision makers are using it as one piece of the tool. They don't let the model make decisions for them. They use it as a tool to help inform their decisions that involve more than just quantitative baseball data.
Yeah, that makes sense. And so you were saying that, basically models are wrong. How do you, is there a case, your work with the teams where you, a case where a model was really hard to develop for you and you really learned something from that because, I don't know, you discovered a new method was really useful in that case and you didn't know about it, or you were looking at the problem from an angle that was not useful, and then changing the way you were thinking about the problem made the difference. Basically, is there a big mistake you made at some point that really made you better as a modeler?
I made a lot of mistakes. Lots of mistakes.
Well,
the mistakes were more common than the successes, I think. And you learn. I learned a ton the whole way through. You come into it with a whole bunch of biases. You want to do things in an sort of an idealized Bayesian way and using best practices. And, want to use Gaussian processes for everything because they're cool and useful and flexible. But, sometimes you force it a little bit and you come out with nonsense, and you got to go back to using a spline or a linear model, and that's fine, right? There's no shame and so some of the answers that ended up being more effective sometimes were kind of the hackier approaches that were a bit of a compromise, but they either ran more efficiently or they produced estimates that were, there was always a sniff test, right? You'd present the results of a model, and then the front office and the others that were making decisions would say, well, this doesn't make any sense. What's going on here? And that's where you learn, right? Where your model is wrong is where you learn and you make it better. So it was a continual, it's a really nice example of, iteration and kind of continual model expansion, or sometimes model contraction, it's simpler rather than more complicated. But lots of valuable lessons.
I can definitely resonate with everything you just said. From my limited experience for now, I've seen both, where I've been able to, sometimes the Bayesian workflow as you see it on the poster really works awesome. And you can increase the complexity of the model kind of linearly. But then at some point, so model expansion, as you were saying, but then at some point you hit a wall and that doesn't work at all. You don't know why. And then you try to sample, then everything, everything breaks and so on. And then you're like, okay, what's happening? And then you have to basically do model retraction, as you were saying, where okay, now I need to remove parts and see what's breaking. And also something I find can be costly, intellectually, is but I know I'm making the model less good if I remove that stuff. And that's that can be weird, right? You're but I don't want to remove that because I know mathematically it's way better to have that in the model. But then, on paper, but then the model doesn't sample, dude. So, you have to remove something. I find that sometimes, heart crushing.
It's never a good idea to hold on too tightly to any particular model or to fall in love with a model, I grew up in my educational career, sort of embracing model selection and model uncertainty and the value of having more than one model. And I think that's very important because you sometimes will overinvest in a model.
Yeah.
You'll hold on too tight to it.
Yeah.
And you should really hold them very loosely and be prepared to start it. Sometimes you just have to start over again.
Yeah. Mm-hmm.
It's like the Concord fallacy, right? You don't, because you've invested all the time in it doesn't mean you should invest more.
Yeah.
It might be time to trash it and start over again with, something similar, or just, make it simpler or strip out your favorite piece that makes it really cool.
Yeah.
Doesn't work as well.
Yeah. Kill your darlings, right?
Kill your darlings.
Yeah. It's like writers talk a lot about that. But yeah, I mean sunk cost fallacy, basically. Yeah. And I find something that's helpful for that workflow is Bambi, if you work with PyMC, because I'm using that more and more because it's just super easy and fast to spin up a model. Like, especially now that there is splines, there is HSGP. I'm using more and more structural time series. So I was talking to Tommy Capreto the other day. I was like, I'm probably going to try and add some structural time series stuff in there because, like in PyMC, you can do everything in PyMC, but it's very custom. So it's like, then the sunk cost fallacy can be higher, I find, at least for me, because it takes longer to build the model. So then you're like, but I don't want to throw all that structure away and then start over.
Well, at some point you'll be able to ask Claude to do it, and they'll just write you 5 different models and just run them. But we're not there yet.
No,
if anybody's ever tried to build PyMC models with ChatGPT, that doesn't go so well.
Yeah, don't do that at home.
But yeah, I wonder what that would look like in Bambi, the structural time series model. At what point do you outstrip Bambi's ability to keep things simple while making powerful models?
Yeah, that's definitely. I'm always taking Bambi to the limit, so I think Tommy hates me because I'm breaking Bambi all the time.
So he's told me that he hates you.
Yeah. Oh, yeah. Okay. So that squares out with his behavior with me. But yeah, so I'm always, messaging you like, hey, I think I found a bug, blah, blah. I think yesterday I found a bug again. And so yeah, I think one time I sent him the model I was trying to finish. He was like, when I'm developing this stuff for Bambi, I never think that people are going to build such complicated models. Like I'm doing that for just a simple model.
Yeah.
And but that's super helpful because then you can spin up a lot of models. You can do model comparison. And then once you have your kind of final model, then you can spin up the PyMC model if you want, and then really custom everything so that sampling is way smoother.
Yeah.
But for development, you don't need to have, the perfect model with no divergences, no perfect effective sample size, blah, blah. If you don't have 1,000 divergences, you're already in a good direction, right?
Yeah.
So,
or you can start, by not doing MCMC sampling from the get-go. You can just use fine map or use ADVI and get kind of approximate answers in a shorter period of time. Because for me, that was building the models didn't take long. It's waiting for them to finish running.
Exactly. Yeah. Same for me. Same for me. And that's actually a good point that I personally don't use enough, but I should, and I will now that you mention it. But so basically in the modeling process, in the development process, you would use a lot of just fine map or even ADVI because that gives you a full distribution. And then
if the parameters are in the right direction, at least. And
then if that's validated, then then let's build, the full production stuff. Yeah. It's like building a crappy car, but see how far it can go. And then, let's build the whole Aston Martin then. Okay. Yeah, that's pretty good. I like that. Well, also, something I found more and more useful personally is doing, even before using the real data, especially because, the data at the Phillies, I think were also the same, really huge. And so that's a lot of time, as you were saying, waiting for the model. And so even before that, to validate the structure of the model, what I do more and more is simulate fake data.
Yeah.
That Claude can do pretty well.
Sure.
Yeah. So
parameter recovery.
Yeah. And then use the fake data to do the parameter recovery for the model and simulation-based calibration, all that stuff. Once you validate that model, well, at least you know that the structure is good.
Yep.
if your data actually follow the structure. That's a big caveat. That's a big assumption. But at least then I find that when I go to the real data and I feed the model, when I get the problems, I know that it's not really because the structure of the model is wrong. And that helps quite a lot, because now you can fine-tune the model in a way that's like, okay, so then probably it's because I need to use the non-centered parameterization here instead of the centered one, or the priors maybe are too tight or something like that. But it's not like, maybe I'm completely wrong and I should use another structure. And that kind of limits the questions you have.
Can you get Claude to create data that looks like the data that you're actually using? Or in my experience, when I do that, it gives me kind of lousy data. I wonder if you can get it to look at a data set and say, give me a similar data set with known parameters, if you've tried that or not.
Oh, no, I've never tried that, but I will. That's very fun. Yeah. No, usually I give it the, I describe the data generated process I want, and then I modify the code because there is always something, that it didn't get, like it's not doing exactly what I want, but at least I have the boilerplate and I can just fine tune the parameters and so on. But yeah, I'll try that next time. That's definitely cool.
Yeah, I have no idea if it works, but
yeah.
I've underutilized that so far, but I'm sure it's coming.
And actually, Tommy Capreto has a very new blog post about that, how to do data simulation with PyMC. So I'll link to that in the show notes, because that's very useful, especially for simulation-based calibration. That's super helpful. So yeah, definitely we'll do that. And so yeah, actually, you already mentioned splines, Gaussian processes, stuff like that. And I know, when we do teachings and so on, and even myself sometimes, I'm like, I can get into kind of a analysis paralysis, where like, well, I don't know, on that kind of data, I could fit so many structures and models. I don't even know where to start, So how do you handle right now in your, current job with PyMC Labs, or even when you were working with the Phillies and Yankees, how do you go about starting these cases?
There's two approaches. You can start with this simple model, a linear model, and then see where things deviate from linear. So start simple and work your way to more complex. But GPs are always a good starting point, because you're not constrained to any functional form. And you can go in the opposite direction, start with a very flexible GP prior. And if things look simpler, you can remove the GP and put something in that's easier to compute. But GPs are hard to beat there, because you essentially let the data decide. There is some skill associated there, because setting priors with GPs can be a little trickier than for a regression model. And so, buyer beware. But and given how easy they are now to set up, and the fact that we have HSGPs that work almost like linear models anyway, those, I think those are pretty attractive as kind of a starting place.
Yeah, I mean, HSGPs have really changed the game for me, at least for GPs, because that's also really what I like about GPs, is that you have very flexible functional form, and at the same time you can put a lot of domain knowledge in the priors, especially because the length scale and the amplitude are interpretable most of the time for your use case. The tricky part is when you're using an inverse link function in the model, then you have to do the math to convert the amplitude and length scale, but that's not too hard. And so you can put domain knowledge here, and then you let the data guide the functional form, which is really powerful and quite hard to beat. And also with HSGP now, it's just way faster and easier to fit, like even on really big data, which, I mean, I've done that already.
Yeah, the only thing it's missing is, of course, you don't have all of the kernels available to you. And doing multiplicative and additive kernels is challenging. So that will evolve, I think.
Yeah. I mean, even with PyMC, you can already the additive kernels. So like we have a tutorial up on the PyMC website that I co-wrote with Bill Ingalls. And so in the advanced use case, we show
additive kernel.
Yeah.
Good.
We show people how to do the additive kernel and also hierarchical HSGP.
Yeah.
So that's pretty cool.
Mm-hmm.
You have to be, we'll see, like, because the covariances in PyMC, they are not vectorized for the number of GPs you have. So if you want one covariance per GP, you have to write the power spectral density by hand, which is, a bit challenging. But something I have in mind is trying to do a PR on PyMC for, like, basically to vectorize the covariance in that dimension so that you can just, have, like, covariance shape equals blah in your broadcast it automatically. But the thing is, you have to, the power spectral density changes, like, for each kernel. I'm guessing that's why Bill didn't do that out of the box, because it takes time.
Could be.
Yeah.
And
I mean, talking about GPs, so, I'll try to release this episode once the PyData videos are out, so that we can put our tutorial in the show notes, so that people who are really, like, interested in GPs and HSGP, they can check that out. Something also I think is interesting to talk about is, since we're talking about time series, structural time series, right? Because I had Jesse Grabowski on the show the other day, and he's really a structural time series guy. He's, like, absolutely amazing with that. Really a big time series wizard.
Yeah.
And he did, like, incredible work on the PyMC experimental side with the state space module.
Yep.
How do you balance these two? Because in my experience, you can do structural time series with GPs too. So why would you even want or need a structural time series?
I mean, for me, structural time series is all about separating the concern of projecting quantities of interest from the observation process, so that you're not wasting time projecting noisy variables forward. Right?
Yeah.
So you just have these two linked but independent processes, whereby you can, in baseball, for example, you can have a model for whatever contaminates your observations. It could be, issues with, Hawkeye sensor, or, in the many ways that baseball data can be contaminated by the observation process. You can separate that from the modeling the changes in the underlying variables that you're interested in. So as much as possible, you're projecting signal forward, because projection is hard enough as it is. So if you can remove as much of that noise as possible at every step. And so, as you say, you can use a GP for that projection piece of it. And it's very handy having these, having, say, multiple length scales, so that you can model how the process changes at potentially different time scales. Like in baseball, you can have within season variation. As the season progresses, you get changes in, pitchers' velocity and so forth. And then there's changes kind of from season to season, and there's kind of, short to mid to long-term career variation. And you can do all of that within the context of a GP. And then, but it's nice to have these latent GPs like the Hilbert space, that then you can put arbitrary, likelihoods on that, and deal with skews and multimodal stuff, all of that other.
Yeah, definitely. I mean, and that's something we'll show this afternoon, basically, where we'll fit a model with three GPs. One, we'll use soccer data because, it's the data, because it's great, exactly. But we'll have a short-term GP, medium-term, and long-term, where the long-term would be like an aging curve. It's actually interesting to see the GP peak of that parabolish curve of the aging curve of the players. You can also definitely see the survivor bias in this, because which we'll do this afternoon, we'll fit the GP on a subset of the players just for efficiency. And so you can see that if you do that on the whole data set, the aging curve will look a bit different.
Yeah.
Because if you do this on a subset of the players, then you'll see that the aging curve picks up a bit at the right, which is wrong, right? Because like a player who is 40
effects.
Exactly. It's like Messi and Ronaldo effects, basically. Yeah. Because I have them in the subset that will fit. But that's funny. But yeah, so basically you could do that. Like that would be kind of the way to do a structural time series with GPs, right? You could have like the aging curve would be the trend, I guess. Then you have the middle, the medium term GP, which is within season effects, and then you have your short term covariance kernel, which would basically just pick up the noise, which could be the equivalent to doing kind of a step linear trend in a parametric time series model where you add some autoregressive component for the residual.
Sure. Yeah, and you also don't necessarily have to estimate the length scales, right? It can be a design decision where I'm interested, this part of the GP or this GP is specifically for modeling within season variation, for example, and you set a length scale that's appropriate for that. And then you have another length scale for longer term stuff. And because length scales can be hard to estimate properly anyway without highly informative priors. So if you can skip that, then all the better. And again, there's something you can change. It's sort of a lever that you have to pull if you need to.
Yeah. No, it's a very good point because in my experience, length scales, I think like I must have done one GP model where the length scale was learned, but most of the time it's basically the prior.
Yeah, I think the posterior is very flat across a lot of the interesting length scale variables values.
Yeah.
So
I think I remember I was talking with Bill about that, and I think he told me that it's also because there is an identifiability with the amplitude, and so basically you kind of can only learn one of the two. Yeah. And I don't remember why. I think it's a multiplicative and identifiability. Maybe you remember better than myself.
I don't, but that makes sense.
Yeah. So basically, very cool models, and I definitely encourage people to check out the GP video. Now, so we've talked about baseball and sports quite a bit, and so we'll transition out because I don't want to, have all the episode about that. I would, but I'm guessing some listeners are like, okay,
enough with
the sports stuff, guys. So you're not working with the Phillies anymore, actually.
No.
Now you're working full-time with PyMC Labs.
That's right.
Which I take a bit personally, I have to say, because you joined PyMC Labs right after I left to work with the Marlins.
It's not an accident.
So yeah, I'm guessing, probably Tommy Capreto told you to do that.
Quick, get out.
Get out, Alex is getting into baseball. Please come here. So yeah, basically what are you up to these days now, Chris?
Yeah, living the dream, right? As Thomas would say, we always wanted to, have PyMC as our full-time job. So wanted to see what that was like. No, it does give me more time to work on PyMC related issues, obviously, as the two are separate, but correlated. Yeah. I do get a lot more time to spend on that sort of stuff. And just learning, a lot more of kind of the business of statistical consulting and productionizing PyMC models and just seeing it in different contexts. I would like to, part of it is a desire to do some business development on the sports analytics side and looking at other sports maybe outside of baseball. And we've talked to a few potential clients there. And that's all new to me too, sitting on sales calls and things like that. It's not sure it's something I'm particularly good at, but it's always good to learn. Yeah. And you meet, it's great to break out of the baseball bubble, at least for a little bit, and see what the rest of the world is like. So it's great. And as you know, it's a great bunch of scientists at PyMC Labs, and everybody is way smarter than me, and everybody's very nice and congenial. So it's just a nice place to work. So it's great, for for the present, as far as I'm concerned. So
Yeah.
and doing lots of interesting projects, things that I never thought that I would work on. So that's always the interesting part is having a wide variety of clients, and there's a lot of opportunity. There's you have the opportunity to learn and to not be afraid of the imposter syndrome, and
Right.
I can work on modeling bonds or something like that. Even though I'm not an expert on it, I can still contribute in a meaningful way. So it's nice. It's always good to learn. Like I'm definitely a lifetime learner, and I find I get bored if I'm not learning.
Yeah.
So and it's hard to. I think it would be hard to get bored doing this.
Yeah. No, definitely. I mean, completely agree. And it's like, great bunch of folks out there, and working with them for the last few years has been absolutely amazing. And great environments, like just only positive things to say about that.
Yeah, and we deliver a lot of workshops and tutorials, and I like doing those. That's kind of the aspect of teaching that I enjoy from my time at Vanderbilt as a professor. You're not grading papers, but you're engaging interesting people who are keen to learn how to apply Bayesian methods better, or whatever the topic has to be.
Yeah.
So doing a fair bit of teaching as well, which is great. And then having some time also to with my PyMC BDFL hat on, trying to apply for grants to help us increase the rate of development and support and sustainability for the project in general. And PyMC Labs affords us the opportunity to do that.
Yeah.
Very synergistic activities.
Yeah. And so you were talking about being a lifelong learner, which I guess like all the listeners identify with. What's something you're learning these days, technically? Like, is there a method you're really interested in, something you're really curious about, and you're like, oh, yeah, I've always been curious about that, but I don't know how that works. Yeah, let me check that out.
Well, I'm trying to learn PyTensor a little bit better. I always knew it kind of as on a very superficial level, so it's nice.
So PyMC's backend,
PyMC's computational backend, but more specifically on the methodological side, digging into very newer variational inference methods. It's become, I think, a hot topic of research with sort of the performance constraints of MCMC, and variational inference becomes attractive. And we use it a lot in baseball, but some of the sort of default methods these days tend to be, there are compromises and trade-offs. And so looking into things like Pathfinder and normalizing flows and things like that, digging into some of that has been really interesting. We've got a Google Summer of Code student, Michael, who's just finishing up implementing Pathfinder for PyMC. So we're working on getting that going. So I'm looking forward to kind of improving. I think the VI side of PyMC has been neglected for a long time. Max did a great job way back when, and there hasn't been as much activity on that side of things. So
I mean, I guess it's also because like we have these new with these new algorithms coming here, which are like really, really good.
Yeah.
And so that means we should probably be able to use Pathfinder directly in a PyMC model in a few months.
Who knows? Yeah, it's early days still, but it's still a sort of in a sort of full R&D low place right now. So we're not quite sure where it is yet, and there are we've got some ongoing work getting them implemented into PyMC, and not just relying on the blackjacks one that we currently had that was kind of underutilized, and seeing how PyTensor might be able to speed that up.
Okay.
And then in parallel with that, looking at normalizing flows. I think Adrian's been doing some stuff on the NumPy side, making normalizing flows easier to do. So hopefully all of this will fall into place kind of at the same time, and you'll be able to use that to make VI better.
Yeah, and the idea here would be like
always in PyMC, right? That would work out of the box. So instead of doing pm.sample, you do pm.sample, sampler equals Pathfinder or
pm.fit is what it would be.
Yeah. Oh, yeah. So pm.fit, Pathfinder, or normalizing flows. And then, as usual, you get back your inference data object with the posterior distributions. Is that what that would look like in your...
Yeah. I mean, it's just all, it's a bit mysterious. It was sort of working, kind of not working for unknown reasons. Just the simple 8 schools model was not running properly, but it would work on other models. And so Michael's done a good job of kind of digging in to see, where things might not be working. And, it currently runs a lot faster in Stan than PyMC. And why is that the case? So again, it's sort of in an R&D place right now. And hopefully in the coming months, you'll see new functionality appear.
Yeah. Super exciting. Yeah. I'll definitely use that because, as you were saying, that's useful in baseball.
Yep.
So I'll definitely do that. Something in the meantime that listeners interested in can already use is Bambi is plugged into Bayesian, which is Colin Carroll's implementation of... So I don't know if it's normalizing flows. I don't remember which algorithm it is, but you have a bunch of algorithms available with Bayesian. I think normalizing flows, but not Pathfinder or the other way around. Anyways, if you go to the Bambi's website, I'll put that in the show notes. There is a notebook demonstrating the alternative samplers, and you can already use normalizing flows with a Bambi model through Bayesian.
Very cool. Yeah.
Very cool.
Need to dig into Bayou. Haven't looked at it in great detail. We had normalizing flows in PyMC 3 for a time.
Yeah.
But they didn't perform very reliably. We ended up getting rid of them. So hopefully they will be more robust this time.
Yeah. That's so exciting to have all these different stuff and like also being able to plug into other packages and using the best practices from somewhere and you just plug it in. That's incredible. Honestly.
Yeah, that's where where we really want to get out there and get some grants, some R&D grants to accelerate some of this stuff because it's really helped in the past with Google Summer of Code students and having kind of their time protected so that they can, because the core developers spend a lot of their time just triaging bugs and, making the current functionality work and work better. It's good to have resources to help us do innovation and new functionality. And so hopefully we can get some funding to help us do that.
Yeah. So folks, you've heard it. Like if you have some free time to help us for that, contact Chris or myself, or if you know about a grant, or if you even have money, you just want to give us money, well, it's just, we're here,
That's right. Well, that's why we like doing PyData meetings and hackathons and code sprints because it brings new talent into the fold that, some of the attendees don't really even know what Bayesian methods are or what PyMC is, and they come and hack on the code for a little bit, and you never know where the next Bill Engels or next Maxime will come from.
Yeah, definitely. That's true. And actually, is there, what's your, so that's like the short-term vision for PyMC. What's your medium-term vision for the package stack? Something in particular you'd like to see in there, something you'd like to change?
Well, that's a good question because one of the things I'm trying to do now is come up with a draft roadmap, and my vision doesn't really matter. Like I'm the BDFL, but this is very much a community-driven project. So I'm interested in what the core developers want to see and what the larger community wants to see out of the package. And, I know a lot of the core development team barely has time to stop and think about these sorts of things because of kind of the immediate issues that are being addressed. But I think that's a question we'll have to answer. What do we want to see PyMC do in the future and as kind of a larger group? So a lot of the things that we've already talked about, better improvements to variational inference and, GPU, making it easier to run stuff on GPUs and getting NumPy closer and closer to the rest of PyMC and making that easier for people to use. We have a lot of issues with, getting various compilers to work, which, makes it hard to install PyMC using pip, things like that. So maybe getting rid of the C back end once and for all, and relying more on them.
Yeah.
Modern backends as kind of defaults. Those are the things off the top of my head, and there's a long list. And it's a matter of prioritizing them and getting the resources and the people available to work on them. So
as always. And so to close us out, because then we're gonna have to leave to teach the tutorial in a few minutes. But I'm curious, now that you've started to work with labs, and talking to different clients in different industries, what has been your biggest surprise? Something you weren't expecting to see, or a use case.
Biggest surprise. I don't know. My biggest surprise is kind of the number of people that know about Bayesian methods and want to use Bayesian methods that don't have the resources to often do them, which is why they come to PyMC Labs. So we get so much of our business not from us going out and knocking on doors, but people coming to us.
Yeah.
And so I've been pleasantly surprised at kind of how well things have gone, and the fact that we have no shortage of business, and that reflects kind of a desire for the analytics community in a variety of different settings to use these methods, and I think it's kind of been helped along by things like PyMC marketing and these more Causal Pi, some of the specific packages that PyMC Labs has built to make it more obvious to potential users how valuable it is. So maybe the biggest surprise for me is kind of how well known it's become. It's gone from being a niche, had trouble getting papers published, academic papers published if they were Bayesian, without p-values, to the entire seems like the entirety of industry wanting to use these methods to help them sell products, or
that's true,
stocks, or whatever it is. So I've been pleasantly surprised at the scope and the breadth of the as I guess just call it the community and industry growing the way that it is.
Yeah, it's a very good point. Like, I remember back in 2017 when I started learning that, it was really a niche thing where you had to justify why you were doing, using Bayesian methods. And now I feel like the fight is basically won, where it's like you don't really need to convince people to use those methods most of the time. Like, from time to time, but it's really, really less and less. It's clearly like common to use this method, so which is like for us amazing, of course. And I think, as you were saying, like at Labs we've been blessed with grateful, with how many, like that many clients who are interested in it.
And amazed that it's just a group of talented people, and I'm always amazed, not even surprised really, because it is a talented group of developers and data scientists and statisticians at the range of applications. A client could come along with in a completely new industry, and we can help them in pretty short order get up and running with a model that's useful to them. That's pretty cool.
No, for sure. Awesome. Well, Chris, I think we'll call it a show. Of course, I'll ask you the last two questions I'll ask every guest on the end of the show. You've answered them 5 years ago, but maybe the answer changed. So first one, if you had unlimited time and resources, which problem would you try to solve?
Unlimited time and resources, which problem would I try to solve? Ooh, and I can't even remember my
me neither
from last time.
So that's good. That means we get another independent draw from the
exactly
from the lake.
Independent draw from my mind.
Exactly.
Unsolved problem. I assume you want like a Bayesian problem.
No, that could be anything you want. No, could be even coming, with a better version of pizza.
Right.
Like whatever you want.
Yeah, I don't. Well, I guess with the election shortly in our rearview mirror, it would be, fixing the analysis of polling data.
Yeah.
That may be an impossible. That may require unlimited resources, but that still seems not to work very well. So I would say, yeah, coming up with better ways of extracting information from voters.
Well, happy to help on that if I can. And the second question, if you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
Dead, alive, or fictional? Having dinner. I would have to say, and again, I can't remember what I said last time.
Yeah, me neither.
Okay. I'm going to say Bill James, just keep baseball on a sort of a baseball trajectory. One of the very early sabermetricians applying quantitative methods to baseball. And I've never met him before. And it would be interesting to pick his brain and what he thinks of the current state of analytics in baseball.
Yeah. Definitely, yeah. So I would definitely like to join that dinner. So please let me know, yeah.
Okay.
He's still over at the Boston Red Sox, right?
So
yeah, okay. I think Tyler Birch, who's contributed a bunch to PyMC and Bambi. I think probably Tyler knows Bill, It's like, Tyler, what you're doing?
Might be sharing an office right now.
Ah, exactly. Invite Chris, please. Awesome. Well, thank you so much, Chris, for taking the time again.
See you in 5 years.
Yeah, see you back in 5 years. Like French presidential elections, you have your 5-year term, and then you come back to tell us how amazing you've been.
Yeah, I'll come up with better answers to these questions next time.
And I will try to give you the questions in advance this time. Awesome. Well, thanks, Chris, and we'll see you whenever you want on the show.
Thanks, Alex.
This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and follow the show on your favorite podcatcher, and visit learnbayesstats.com for more resources about today's topics, as well as access to more episodes to help you reach true Bayesian state of mind. That's learnbayesstats.com. Our theme music is Good Bayesian by Baba Brinkman, feat. MC Loss and Mega Ran. Check out his awesome work at bababrinkman.com. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. You can support the show and unlock exclusive benefits by visiting patreon.com/learnbayesstats. Thank you so much for listening and for your support. You're truly a
good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.